right, so we're going to prove the circumcenter theorem, which states that a point is the circumcenter of a triangle if and only if it is equidistant from the three vertices of the triangle. So as you can see, these are the dotted lines for the three vertices, and we're going to try to prove that these three dotted lines are all congruent, right? So the first part is we're going to do P implies Q. We're going to suppose O is the circumcenter of triangle ABC. So what it means to be a circumcenter is that all of these are perpendicular bisectors that meet at that O, right? So, of course, this implies that OD, right? OD is perpendicular to AB, where AD is congruent to DB. All right, and then of course you can see that these dotted lines here, if this is the perpendicular bisector of AB, which it is, right? Because OD is perpendicular to AB, where it cuts AB in half. So by the perpendicular bisector theorem, we know that if we have these two conditions, that AO is congruent to BO, right? So remember, that's only this part. We also know if O is the circumcenter, this means that OF is perpendicular to BC, where BF is congruent to FC. And then again, by the perpendicular bisector theorem, we know that OB is congruent to OC, or I should put BO is congruent to CO, right? And then finally, the last one, we have OE is perpendicular to AC, where AE is congruent to EC. And then, of course, if this is the perpendicular bisector of AC, this implies by the perpendicular bisector theorem that AO is congruent to CO. And look at what we have here. This means we have AO. AO is congruent to BO. And of course, BO is congruent to CO, which is exactly what we wanted to show. We wanted to show that all these three vertices, right, are equidistant from this point, right? So let's go ahead and do Q implies P now, right? So in this case, we're going to suppose that O is equidistant from the three vertices, right? So suppose O is equidistant from the three vertices A, B, and C, right? So if O is equidistant from these, this implies that AO is congruent to BO, which is congruent to CO, right? Okay, so we're going to let OD be perpendicular, right? We're just going to choose that OD to be perpendicular to AB, OE perpendicular to AC, and OF perpendicular to BC. Right? We're just going to choose these points and we're going to draw these lines that are perpendicular, right, to those points on this line. And of course, knowing that AO is congruent to BO and stuff like that, we're going to show by the perpendicular bisector theorem that this is not just a line that is perpendicular to the side, it is the perpendicular bisector, indicating that O is the circumcenter, right? So we have AO is congruent to BO, and OD is perpendicular to AB. So this means, by the perpendicular bisector theorem, that AD must be congruent to DB, right? Similarly, we have BO is congruent to, so BO is congruent to CO, and OF is perpendicular to BC. So this implies, by the perpendicular bisector theorem, that BF is congruent to FC. And then lastly, we have AO is congruent to CO, and OE is perpendicular to AC. So this implies, by the perpendicular bisector theorem, that AE is congruent to EC. Okay, so this means that OD, OF, and OE are perpendicular bisectors for, so OD is the perpendicular bisector for AB, OF is the perpendicular bisector for BC, and OE is the perpendicular bisector of AC, respectively. Right? So, if all of these perpendicular bisectors meet at this common point, this means that O is the circumcenter of triangle ABC, right? So we've shown that if all of these vertices are equidistant and they meet at this point, if this point is equidistant from the three vertices, right, then this point must be the circumcenter of this triangle. And that is the proof of the circumcenter theorem.